morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today we will discuss the question bank on the basis of the data pre-processing and feature selection. So we will see one by one. In previous class, we have discussed the question bank on process of the data, flavors of the data. So now we will see one by one. First question is that, should your test data be cleaned the same way that the training data is? So our answer is yes. Actually, you can test your data as the same way that the training data. So you should do the same cleaning on your training and the testing data. Same cleaning. We will not take any other cleaning technique. You can use a same cleaning technique for the training purpose and for testing of the data. Because the test set reflects the system performance against your real-time data, and for this you will need the performance of the cleanup of data in the test set. So next question is that, when you sample, what potential sampling biases could you be inflicting? So sampling bias generally, when it will occur, actually when some members of the population are systematically more likely to be selected in a sample than the others. So sampling bias only occur when the population are systematically more. So generally it is called as ascertainment bias in medical field. If you are taking the medical as an example of the medical field, then we can say that it is the ascertainment bias, and sampling bias just limits the generalization ability of findings. Because why we can say that it's just threat to external validity, and sometimes we can say the population validity also. So in other words, we can say findings from biased sample can only be generalized to population that they can share some characteristics with the sample. So sampling is totally based on your population set. Then next one is that, what do you understand about information gain, and also explain the mathematical formulation associated with it. Here we have to explain about the information gain. What is information gain? How we have to calculate the information gain? So we can calculate the information gain by reducing in entropy or surprising from transforming a data set in some way. So it's commonly used in construction of decision trees. Definitely here we have to construct your decision tree from the training data set. And by evaluating the information gain for each variable and selecting variable, it will maximize the information gain. Here you have to select variable, you have to evaluate your information gain for each variable, and because of that, what will happen? So it will maximize your information gain, and this information gain will help in turning the minimizes the entropy, and it will split this data set into group for effective classification. So information gain can also be used for, we can say that, the physical selection. How it will be usable for the information gain? So for that we have to evaluate the gain of each variable and in the context of the target variable. So in this slightly different uses, so calculation is generally just, we can refer as the mutual information between two random variables. Now next one is, how can one handle suspicious or missing data in a data set while performing the analysis? So here we are talking about the suspicious data, missing data. When we are dealing with the missing data or suspicious data, generally data scientists can use two primary methods for solving this error. One, imputation, and another can be removal of data. So just imputation method, what will do? the imputation method, just it will develop the some reasonable guesses. But for what reasonable guesses? They will develop the reasonable guesses for your missing data. And it's most useful when the percentage of missing data is very low. So if the portion of missing data is too high, the results lack natural variation that could result in effective model. And the second option is that to remove data. There are only two methods, one imputation and another one is removal of the data. In imputation, we will develop some guesses on the basis of the missing data, and when we can develop these guesses only when your missing data is low. But if your missing data is too high, so definitely your result can be varied. So that data or that result it will be very effective or not, we don't know. So second one is that the second option is the removal data. So when dealing with the data that is missing at random, related data can be deleted to reduce the bias. We can delete the data. And just removing data, maybe it's not the best option. But if there are not enough observation to result, so at that time you have to use the removal of the data. In some situation, observation of some specific events or factors may be required. Every time we can't use the imputation methods, every times we can't develop the guesses related for the missing data. So sometimes we have to we have to develop some guesses, and sometimes there is need to remove removal of the data. So it depends on the situation, which situation is occurring. So on that basis, you can use any one of the technique, either imputation or the removal of the data. So before deciding which approach to employ, data scientists must understand why the data is missing. So definitely before taking any action so you have to think that why data is missing. What is the reason? You have to find out the reason for that, and then you can take the particular decision which method you have to use. Either removal of data or imputation. In imputation, just you will develop the guesses related to missing data. And removal data means just you will delete the data. So these things are related to missing data or suspicious data. Then next question is, explain the general principle of an ensemble method and what is bagging and boosting in the ensemble method. Ensemble. This word is totally related to machine learning. That means we can say ensemble is just a machine learning concept where multiple models are trained and by using the learning algorithm. So we can say that the ensemble is just machine learning concept which is using the multiple models for training the data set by using the learning algorithm. And bagging is way to decrease the variance in the prediction by generating additional data of training from data set using the combination with repetitions to produce multi-sets of the original data. So bagging, just with the help of the bagging, we can decrease the variance which is available in the predictions. And ensemble means just we can say the machine learning concept which is using the multiple models. So boosting is iterative technique which adjusts the weight of an observation which are based on the last classification. Definitely, whenever we are talking about the ensemble method or machine learning method, machine learning algorithms, there we are talking about the classifications also. So bagging and boosting, both techniques are related to classification, both techniques are related to machine learning. Bagging will decrease the variance and the boosting is just iterative techniques. It will be totally depends on based on the last classification. So if observation was classified incorrectly, so definitely it will try to increase the weight of this observation. We don't want the weight so much weight for this observation. We want less observation. So boosting in general builds strong predictive models. So next one is that explain the steps in making a decision tree. So decision tree is is analysis technique. So again, it can use the both small and the large corporation for making various decisions related to management, operations, marketing, capital investment, or strategic choices. So there are different steps for creating the decision tree. So step one is that start with one idea. Start with one idea means what will happen? Just we have to design our decision tree diagram with one main idea. What is your motto? What is your objective? So according to that, you have to design first your decision diagram with one idea, and then you have to start to build a tree. Analysis should add decision node first before adding single branches to the various decisions they are deciding the between. So next, step 2 is that add chance and decision nodes. Now after including priority, definitely in first step we are deciding the idea, we are deciding what is, we are checking that what is our objective. So on that objective we are designing our decision tree diagram, and then after that we are adding a chance and the decision nodes. So in every decision diagram we have to add some chance and we have to add some decision nodes also. So after including your primary idea in the tree, you have to continue for adding the chance or decision nodes. After each decision, your tree will be expanded. So a chance node generally needs alternative branch to be added after it, because there could be more than one outcome for making the decision tree. Definitely sometimes we will get so many outcomes, so on that basis we have to make the decisions. So next one is that expand the tree till the end points. So keep adding chance. Here we have to keep adding the chance and decision nodes to each branch of the decision tree. So after that only you can reach your end points and you cannot expand the tree any further. So at this point, add end nodes to your tree for highlighting purpose, for highlighting the completion of the tree creation of a process. So next one is that calculate tree values. First step, start with one idea, then add chance and the decision nodes. Then third one, expand the tree till the end points, then calculate tree values. So here you have to calculate your tree values by using the one of the formula. So once after completing adding the nodes and the chances to your tree, you have to analyze the outcomes of each decision. So you have to move from each node. Every node you have to check, and every node you will get different outcomes. So ideally decision tree will contain some monetary values for each of your decisions. So for instance, it will cost your company specific sum of money to build or upgrade a financial plan. So it will also cost less money to create new plan versus upgrading the existing ones. So there is a expected value is equal to first possible outcome x likelihood of the outcome plus second possible outcome into likelihood of outcome, that minus cost. So here we are calculating our expected value, tree values. Then next one is analyze outcomes. After that you have to analyze, you have to predict some outcomes, you have to determine the numerical values for the expected outcome of each decision. So you can easily evaluate your financial decision which is totally based on your business by looking the figures. So highest expected value may not always be one you should go for. So here, though decision could yield high reward, it means that it taking highest financial risk. So definitely here you will get the one or more outcomes, and you have to decide which outcome is perfect according to the situation. So expected value in decision tree analysis comes from your probability algorithms. So there are five steps you have to follow. First one is that start with one idea, then add the chance and the decision nodes. After that, expand the tree till the end points, then calculate tree values, and the last one is that analyze outcome. Next one is explain the feature selection algorithms in detail. So generally the feature selection is just a process for isolating the most consistent, non-redundant and relevant features which are available in the model construction. Generally, reducing the size of data is very important as the size and variety of data set continue to grow. The main goal of the feature selection is to improve the performance of the dataset or predictive model, or it will reduce the computational cost of the modeling. So this is the main aim of the selection algorithm. Just feature selection algorithm related to process which is used for isolating the most consistent, non-redundant, relevant features it will use, and we can reduce the size of the data set by using the feature selection. Main goal of feature selection just to improve the performance of predictive model. Whatever model you have predicted, it will improve the performance. Then next one is that explain each step of data pre-processing in detail. So first one is acquire the data set. Here every step is very important. So you can go through all these steps. First step is acquire the data set. Then next one is import all the crucial libraries. Import the data set. Identifying and handling the missing values. Encoding the categorical data. Splitting the data set and feature scaling. So these steps you have to follow for the data pre-processing. How are decision trees used in classification? Generally, decision tree induction is learning of decision tree from class labeled training tuples. So decision tree induction. Here we can give the training to our data sets and we can learn of the decision tree from the class labeled training tuples. So here decision tree is just a sequential diagram. Like we can say it will look like a tree structure. It will then where there will be internal node and some external node. Internal node means non-leaf node which will indicate the test on an attribute, and each branch defines the result of the test. Each of leaf node or terminal node influence the class label. So there are internal and external node, both are the very important. And internal node means we can say non-leaf node. The highest node in a tree is the root node. For example, this is main node. So here, this will be your root node. It defines the concept wise computer. Like it will predict whether the user at all electronics is likely to buy a computer. So this is just example of the classification. Now internal nodes generally we can indicate by using the rectangle. And leaf nodes are indicated by the ovals. So there are different decision tree algorithm for creating only binary trees. And where binary trees means just every internal node branches to accurately to another nodes. Not more than that. So whereas other can create own non-binary trees. For example, given tuple X for which is totally related to your class label is anonymous, and the attribute values of tuple are checked against the decision tree. The direction is traced from the root to a leaf node, which influence the class prediction for that tuple. So decision tree can be changed to the classification rule. Now, next one is, what are the challenges of the data processing? While data processing, there are so many challenges. So we will see one by one. First one is that irrelevant data. Sometimes, most of the time, whenever we are accessing data, whenever we are searching for some data, so at that time, some unavoidable data, some unwanted data will be available with our system. So unavoidable issues that requires the data cleaning in the presence of attributes in data set that are irrelevant to the problem we are trying to solve. So whenever we want to avoid these things, we want to avoid this unwanted data. So at that time, we have to use different algorithm. So we have to try to avoid this problem, to avoid this irrelevant data. So here, for example, in problem where we want to predict the price of the house, the owner's contact number does not seem to be relevant attribute. So definitely, if you want to check the price of the house, so definitely no need of the owner's contact number. No need means it's not relevant data for that particular example. It's a irrelevant data. So next one is the duplicate data. Sometimes whenever we will access our data, at that time, at the same time, we will get the duplicate data also. So integrate data from different sources may result redundant rows and the columns in the same data set. So that means there are chances to create the duplicacy of the data. Then next one is the noisy data. Noisy data means it will create the errors in measurement, entry, data, while data transmission, and it may lead to invalid, inconsistent, and out of the range values. For example, column representing gender may have unknown coding, that is S, and column to store in DDMMYY format may have an entry 11/30/2021. So this is also example of noisy data. Then incorrect data type. Sometimes we will keep data in different format. For example, data set would generally store in different data types, like integer, float, and string. And the data type in which data column is stored sometimes may be wrong. So this can happen. So we can say that it is an incorrect data type. For example, numerical attribute like the price of house may be stored as a string. So this is totally wrong. Numerical value you should keep in integer, float. So definitely it will give the error. Then next one, missing values. It is seldom a case where values are not missing in a data set, and it may occur due to unavailability of particular instance of data, error in recording leading to noisy data, and consequent labeling as the missing value. So missing values, this is also another problem which is we are facing nowadays. Missing values, and because of that, what is happening? We are not able to access particular data. We are not able to predict our particular output. So sometimes due to the unavailability of particular data, it can create the noisy data. It can consequent labeling as a missing value. Then next one is the multicollinearity. So multicollinearity, actually, value under the different columns can be correlated, such as like correlation may purely accidental. We can say indicative of an underlying relationship or due to duplication of data in some form or the other. Next one, outliers. The outliers are extreme data points which are very compared to the rest of the data. Sometimes we can say outliers are unwanted data also. Every time that data is not useful for us. So we can say that outliers, unwanted data. They can be detected numerically by calculating the data distribution, interquartile range, and the standard deviation. So We can visualize by using the box plot, histograms, scatter plots. Then next one is unacceptable format. The data may be in format that is not acceptable to the machine learning algorithm to apply later in the data mining stage. So unacceptable format, which is not acceptable by the machine learning algorithm. Then next one, too many dimensions. Generally the columns in dataset are known as dimensions. Sometimes we can say attributes, features. So as a human beings, we can visualize data only in up to 3 dimensions. For machines, the dimensions of more than there are not major concern. The interpretability of data reduces with higher dimensions. So data set may be characterized by too many dimensions, making harder to cluster data and obtain meaningful patterns. Next, too many categories. In a categorical variable, there are so many categories. For example, we can say there are different data we are storing in the column format, like locality, to which person belongs can lead to too many categories. So this issue can be observed in descriptive statistic, like we can say the bar chart, which is showing the data category wise. So too many categories can lead to too many dummy variables while transforming the categorical variable into the numerical variable. So these are the references. You can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.